Exercise 1.1, question 3. An army contingent of 616 members is to march behind an army band of 32 members in a parade. So you will have 32 members in front, arranged in some way. I don't know how they're going to be arranged, but you will have 32 members in front. These are members of the army band, and behind them you're going to have these 616 members who are a part of the army contingent. They're behind them. Now, there's something they're telling us how we have to arrange these people. They're saying that two groups of people, the blue group and the red group for us, are to march in the same number of columns. So the way I have drawn it, I have drawn them in that way only, that it's the same number of columns. This is column number 1, this is column number 2, column number 3 and 4. So I randomly drew 4. I did not do any calculations, but this is to help you understand what is it that we're looking for. Now, what is the maximum number? The question comes here. What is the maximum number of columns that you can take in which they can march? So this column thing, let me just suppose, let's assume that it's n columns. Then you want to find the maximum value of n. Now you really need to understand what n is, how it is connected with these 32 people and with these 616 people. For a moment, let's just forget about these 616 people from the army contingent. Let's just think about this army band of 32 members. Now, what you see right now is that no matter how many columns there are, don't just assume this to be 4 columns, but all my 32 members will fit in these 4 columns. That means I will be able to arrange these 32 members equally in these many columns. Now think about it. Just take some numbers. Can I arrange 32 members in 3 columns by having equal number of members in each column? No. Why? Because 32 is not divisible by 3. I cannot equally divide them. If I have 10 members here, 10 here and 10 here, even then that's just 30. So 2 members will still be left out. What if I have just 2 columns? If I take 2 columns, then I can keep them as this. I'll have 16 members in column 1 and 16 in column 2. So 2 columns are possible. Why? Because 2 is a factor of 32. So just how 3 was not possible because it was not a factor of 32, 2 is possible because it is a factor of 32. That means the number of columns that you have, which is your n here, is a factor of 32. Let me just write that statement down. N is a factor of 32. Now let me just clear up this space and let's talk about these 616 members from the army contingent. Okay, similar thing. It's again the same thing. If I have 616 people, can I arrange them equally in 5 columns? I will not be able to do that. And the reason for that is that 5 is not a factor of 616. So I cannot divide 616 by 5. So what all can the number of columns be? It can be any factor of 616. It can be 2, it can be 4, whatever two multiples, 2 factors that came to my mind, I wrote them. So this can be the number of columns. So yet again, just how n is a factor of 32 here, n is also a factor of 616. Let me write that. There you go. Now I will just remove all of this art here because the real idea that I had to bring forward was this, that n is a factor of both of these numbers. So I'll just clear this up and bring this to the foreground. Perfect. Now the idea is when you see that n is a factor of both of these numbers, I can say it at one step, in one step, that n is a common factor of these two numbers. Wonderful. We're getting closer and closer to what we want in this question. Think about it. What is this n? N is really the number of columns. That's what we're trying to find, right? And we already have one property about this n. That is, it is a common factor of 32 and 616. But there's one more thing that the question wants us to do. It says, what's the maximum number of columns? So it does not just want any common factor, it wants the maximum that this can be. Now you know exactly a term for that. What is the greatest possible common factor that two numbers can have? We call it the HCF, the highest common factor. So the n that we are looking for is equal to the HCF of 32 and 616. Now finally it starts to look like the other questions in this exercise. We needed to do all of this inference, we needed to understand all of this, take this meaning out to reach this stage. And after this it is easy. You know how to use Euclid's division algorithm to find the HCF of two numbers. Here are the steps. So let me do that. Okay, so we have to find the HCF. Now we know we have to apply Euclid's division lemma on these two numbers. So when I divide 616 by 32, that is how I will know how to express this. So let's just quickly divide this. This is what you get. And now when you write it down, it's 32 times 19 plus 8. Since your remainder is not 0, you know according to the algorithm, you have to keep applying the lemma one more time on this divisor and the remainder that you have at that stage. Now once you work with 32 and 8, you don't need any long division for that. This is just 8 times 4 plus 0. That means the remainder at this stage is really 0, and so the divisor that you have at the stage when remainder becomes 0, that is the HCF that you are looking for. That means the answer here, the maximum number of columns in which they can march, which is n as I had taken, is equal to 8, and we're done.